Okay, so continue from where we left off. We are saving us in our bit to reproject. So this is reprojection made simple. Let me just put it that way. So we need to give a new name to our reprojected file, and then we need to select a new projected system, coordinate reference system. So we are moving from the round earth to a flat surface. So when we're talking about that in class, you'll be thinking, what is it talking about? Now, it tells you everything is mathematical, excuse me to say. You don't really see anything round, but we are doing it, okay? So I'm gonna put the lake and I'm gonna rename it as Lake UTM, which actually lies on my desktop. So Lake, I'm gonna put an underscore so you can do the same for those who are following. You can just name it like that and then just say, okay, that's it, done. You will see a pop-up saying that multiple operations are possible for converting coordinates between blah, 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 blah. So let's just ignore all that. And then this is what we are going to do. We're going to remove the one which is actually in the projected coordinate system. So I now have only coordinates, data sets which are in the same coordinate system, i.e. I have 26910, 26910 for bounds, 26910 for the DEM, okay? And this is what we can do. We can clip the DEM, like, we can try that quickly. But before we do that, let's bring in the other data set. I think I have the roads, okay? I had created a layer called roads. Let's drag that in. Oh, I didn't. So I think what we're going to do is I'm going to go for pine. I have river and pine. So let's break the river and the pine tree. So pine tree. I hope they are all projected because if they're not, we have to do the reprojection. So we will have to reproject that as well. The pine tree. Let's bring in the river layer. So drag that also into it. And we are going to reproject them and call them UTM. So since we know how to do it, I'm really going to run fast with that. And then hopefully we should be just done in a second. So there we go. That's the pine tree. It's important to give it the right name. Save features as pine tree. Pine tree UTM. So pine tree underscore UTM to differentiate between the one which is projected and the one which is not. So I'm deleting the one which is in the geographical coordinate system. Okay. I know the class is quite quiet, but please. Silence means you agree. Are you okay? It means you are you concur. Okay, so by law, you are happy. You are a happy man or woman. Okay, great. I think this one is okay. The river, what I'm calling river, it's okay. It's in 26910. So I'm fine. All my layers are in the same layer. Let's see if we can clip the raster layer by going to the raster menu. Those who are actually doing it. Okay, so to clip a layer means to cut a part of it. Okay, let me just speak bluntly. We want to just cut a part of the layer, the data set, because it's so big. Are you okay? So it's just like when we talked about the overlay operation of intersect overlay. Are you okay? So the intersection between, say, the boundary polygon and then the DEM polygon. So let's simply go to raster menu, go to extraction, go to clip raster by extent, and then the input layer is my DEM, and I want to clip by a certain extent from a layer bounds. Okay, so if the two are not in the same coordinate system, that is when you have Probably. Okay, George says, please, anyone getting not valid or recognized data source when trying to load layers into the workspace? Okay. And no one has responded, so I'll have to respond to that. Not valid or recognized data source. That probably means you've probably deleted some files. Normally, the files I gave you contain what we call the PLG file, the SHS file, the SHP. So you have about 4 files. If all of them are in there, the one that you want to grab is the one, normally the last but one file. It has an extension of .shp. Okay, so just look for that file, drag it into the interface, and then it will display. Okay, so let me know. You can type back in there if you feel what I say is not working. But if it's working, let me also know that it's working. So I'm going to be clipping, and hopefully it should be a simple process of just saying run, and it should just get done. No errors whatsoever. So you can see that the new layer created is now being, by default, being symbolized using the grayscale, right? So the original one is colored behind it. So I'm turning off all these layers. This is the original we give it. And this is the new one that we have actually clipped, okay? And we clipped it using a certain polygon layer, which is this one. Okay, so I can turn everything off. Now this polygon shape file is actually, okay, the shape file, I created it myself, okay? Can create one myself, like the same way we were doing the on-screen digitize. Okay, no said the SHP file did not work. Okay, so you get the error, not valid or recognized data source. But do you see the thing display? If it's not displayed, one of the things you can do is close it, close the QGIS, open it again. Okay, and then try dragging it in again. Okay. Okay, I hope George is not trying to tell me that, okay, she's actually working. But okay, I believe you, George. So try it again. Okay, try it again and give me a feedback. Okay. Someone is trying to put on their microphone. Please don't try it. Unless you want to say something, of course. So George, please try again. And let's see. I'm going to show you how I did it again. So please watch it. To bring in a shape file, the DM, you can try with the DM. Can you add a DM? Let me know if you can do that. All right, if you can do that, can you add any other shape file? Apart from, so can you add maybe the lake, but you can't add, you know, the bounds. Are you okay? River, but you can add. So can you add any other shape file? So to do the shape file, this is how you do it. I'm going to just show you my Explorer again. So if you watch carefully, you go to where your data is. So mine is on my desktop and it's in the CV Ontario folder, okay? And in there, I have my DEM. That's where I downloaded my DEM so I can drag it. So you simply open it up, drag the DEM.tiff file, tag image format, drag it into the software, okay? CV Ontario, come back to it. We have Lake, we have Pine and all that. I have Lake and I have Lake UTM because I've just created a Lake UTM. And so now I want to drag the lake, let's say. I simply look for, out of these 1, 2, 3, 4, 5, 6, the one that you really want is the AutoCAD shape file source, shape source, AutoCAD shape source. The file with that name is the one you want. It's the main shape file. Another way of doing it is to go to layers, add shape file, then you go and browse. That one is also one easy way of doing it. Okay, so you can go to, let's go to QGIS. And then go to layer to add data. So George, please follow me carefully. It's very important. Add layer, add layer, vector, add vector layer. Then you get a dialog box, data source, dialog box. And then in there, you now browse. So you see vector data sets. So you just go browsing. But then you still see all the files as they are. In some software systems, you wouldn't see everything like that. You see only the ones you're supposed to see. Okay, so let's look at this one. I'm going to actually choose Esri shape files, which actually makes it easier. I think that's the best way to go about it. Choose Esri shape files in this type. So file name type, go for ESRI shape files. Please type, don't talk. Your network is bad, so type in the chat for me. Please, the person who is talking, type for me. Your network is bad. Go and type. Ruben, go and type in the chat area for me. Don't talk because your network is bad. And mute your mic, please. Mute your mic. Okay. Mute your mic, Ruben. If you can hear me, mute it and go to the chat area and put your request, your question there. All right. So you simply to add. You said? You said? Okay. Great. So that's where we are. Add layer, add vector layer. I'm doing it again. Then in the dialog box that shows vector data sets, you click on the button to the right to browse. Then you choose the file of interest. But before you do that, you go to all files. Okay, to the right to see all files. You choose the ESRI shape files. That's the one you want. Then you can choose. So now you don't have so many files. You have just the file that you need to choose. Okay, so this is the one easy way to add the layer. Okay, to add a layer. So I can choose it to go, right? But I've already added it, so I don't need to do it again. Right. Now I'm going to save my clipped extent for the raster. So this DM clipped, okay? I'm going to save it by just saving it. So I'm going to do export, save as, and I'm just going to browse to the Ontario folder and go to DM. And then now I want to put it here as DM clipped. Okay, so clipped. Spelling doesn't matter. So I've clipped it and I've saved it. It's very important. Normally, when you see this sign, it says temporary layer only. Contents will be discarded. So it means this layer, it will be thrown out. It won't be saved. It's not saved on the computer hard disk. It's not. So we can actually get rid of it. We can remove it. So now I have data reprojected. River is also reprojected. Okay. Okay, there's someone is saying something. Sir, please, how did you get the several values under DM? What getting several values? How was I able to query for the values? I think that's what you mean. So look for the identify tool. I think that's what it is. It's up there. It's called the identify features button at the top of the toolbar. You see the identify features button. Okay. Identify features button. Toolbar. Okay, so you just click it and then you'll be clicking everywhere. But please, it's enough. I think you've seen that. So move forward a bit. Don't be too far behind. If you're actually following what we are doing, don't be doing something that we did like 2 years ago. Are you okay? All right, because we finishing this lecture. We want to have some Sunday, isn't it? All right, so let's try and get it done. Miguel, so I hope you're happy. Look for that button and be clicking, and I hope I understand your question. Be clicking around and you'll be seeing the value showing up at the bottom right. Okay, now it's not showing because let me show you why it's not showing. It's not showing because I haven't selected the DEM. Now that I've selected it, it's showing again. Are you okay? Take note of that. All right, so I'm here for you. Where we get stuck, I'm here. So that's a good news. All right, so that's it. We have all our layers. Okay, what can we do with this cell? Is looking beautiful to me. Are you okay? But like some cartoons say, it's cute, yeah, but it's wrong, yeah. But I hope it's not wrong. This one is not wrong. This is really correct. What we want to do, this is a bigger layer. Let's remove this DM. Right click it and remove. So I'm actually basing some of the things I do on last two tutorials, the last two tutorials. Okay, now observe how the shape file could not capture a certain part of the raster. What's the explanation for that? I think that is a good one, isn't it? Okay, so these are all algorithms. Okay, so I can actually bring back all my layers. Okay, I can make the bounds hollow. Can you imagine that? So things like that are possible. I can simply decide that my bounds should be anything like that, you know, it's possible. So give it a color that's more relevant. Instead of black, give it something more cooler than that. Okay, doesn't matter. Okay, all we want to do is to work on the available data, which is within the bounds. Are you okay? Which is the polygon. Are you okay? So we have the good thing about it is that what you are seeing on the board is the summary of everything that GIS is about. Points, lines, polygons, and rasters. Beautiful. All overlaid over a certain geographical extent. Okay? Defined by the bounds polygon. Okay. So before we go, let's go back to our tutorial. Let's be obedient and follow it, and then we can all live happy. So go back to the tutorial, which is always hiding somewhere, but I'm going to find it. Okay, I think it's here. Multicriteria overlay analysis. So step 1. So anybody who wants me to wait can tell me, say wait, type it in the chat box that I should wait, and I will wait for you. If you don't do that after a few seconds, I'm just going to carry on, and we are going to carry on with step 1. It's a procedure. Medical, the surgeons, yeah, they have procedures. 1, 2, 3, 4, get it done. Let's see how far we can go. So if I don't get anyone saying, say, wait for me in the chat area, I'm going to carry on, okay? So I'm going to start, and if someone said, wait for me, I'm still going to wait. Even after a few minutes, I will wait. Okay, so let's get into the spirit of this one. Step 1, the first procedure is browsing to get the data, which we already have, okay? We have a boundary, we have road, we have water, which is the lake, and then we have pine trees, which are, okay, so we have even more. So we get into the spirit of it. Second step, the first step, anyway, because it's the first step, I call that the second step. The first step in the overlay analysis is to convert each data layer to raster. So we are going to rasterize our data. Are you okay? All right. So let's go into our QGIS. QGIS, okay? Germans can see Q, can see Q. Anyway, so that's for you, those who want to learn German. We are going to convert the vector data into raster data. I mean, we're just going to use software, so I don't see why we should even be worried about. We consent so much. So we go to the raster menu, conversion, rasterize. Raster menu, conversion, rasterize. Conversion, then we're gonna rasterize. Okay. But the first step is to actually get the data in the same projection and overlay. Are you okay? Second step then is to go to the raster menu and then do the conversion. Are you okay? So getting the data in the same projection overlay is a whole thing. Are you okay? And we clipped and all that. Remember, all these are important steps. And then we go to the rasterize menu. So you skip the input layer is bounds. We are not interested in bounds. The bounds is only guiding us. So that will not be rasterized. Okay. The lake layer, yes, let's rasterize that. So we're going to start with the lake. Then we go to I think we'll move in a certain fashion. Lake, okay, wait. Then fail to use for a burn-in value. Don't choose anything. Leave it there as it is. Fixed value to burn, put 1. Clear everything and put 1. Output raster size, put georeference units. Then the width or horizontal resolution, we are going to use the same resolution that the DEM is using so that we can do some combinations and some sort of comparisons. So let's find out the resolution of the raster layer. Are you okay? So we should find it in the information under properties. To be in there somewhere. Okay, so I'm just scrolling down. The pixel size is 30, so it means this is a 30 meter resolution image. So we are going to just use 30 meters for our width or horizontal resolution. So we want to call that 30, and we're going to put 30 here. Why can we put 30? You see, you couldn't do that if we're working in a geographical coordinate system, because 30 then will be 30 degrees, and 30 degrees is so huge. Are you okay? So let's move on and do the out. Let's go to the, so we have 30 by 30 squares on the ground resolution, okay? Now let's go and pick the output extent. So we go for output extent, calculate from layer, and we are going to use the bounds, okay? So let's do that. Those of us who are going with me. Okay, so we have an output extent. Then we have assign a specified node data value to output bands. We are going to make that one not set. So this is how I do that. You simply come here. In fact, it's too late, but I can do it again. Let me close it. Raster, conversion, rasterize. Then we come here and put 1 units, georeference unit, not pixels, 30. So because we said georeference units, the georeferencing is actually the coordinate system. See, so you should understand georeference to mean to link an image to the ground for real. Like the image is actually like the ground, it represents the ground. So 30 meter by 30 meter, the output extent again, calculate from layer bounds. Then you click this arrow on the right far right that says assign a specified new data value. Okay, all right. So we should finish this class early, I think. Yeah. let's carry on. Okay, so there is something we haven't done. We don't have the input layer, so it's reminding us. So let's simply put it there. Let's pick it. We are doing the lake. So lake raster, that's what we are trying to generate. Okay, so all things being equal, we should be able to say run, and then we shouldn't get any problems. Okay, so this is our rasterized lake. Okay, to prove to you that that is the rasterized lake, I'm going to turn off all the other layers, and you see that now I have a layer in which there are no values in all other places. There are zero, and every other place where there's a lake, we have 1. So that's rasterization. Okay, we've rasterized our lake. Okay, we've rasterized our lake. So done. So if I were you, what I'll do is that I'll simply save it. So I'm going to export it and call it lake raster. That's a lake underscore raster. It's very important to be organized on your computer. The coding system is fine. You know where it's going to, and the rest, I think, you can just say okay to that. So that's good. We can delete the rasterized layer because that's not what we really want to use, because it's only temporary. We do the same for the other layers. So we are going to just go for the next one. Okay, just so vector to raster, pick the layer. Pine tree is available. I thought we had road, but I think whether we have river, that's fine. I think we have river, that's fine. We don't give any value here, which one? The reference units, 30 meter resolution. So the raster generated will be squares of 30 meter extent. We are always going to use the bounds from which we get our output extent. So it means we are outputting to the same region. Assign no data value. So where there's no data, we just put no on set, not set. Okay. Everything else looks okay. Run it. No errors. Okay. So which one was this? Which one did we just do? Which one did we just do? If you are following, which one did we just do?
Pine tree.
Pine tree, thank you. Means you are following. Okay. Or someone will see that's a teacher's trick of just telling the students that he remembers everything. Pine tree. Underscore raster. So we have pine tree underscore raster. Whoever is talking should stop. It's annoying. Me, I'll tell you, it's annoying. Mute your mic, please. All right, so that's it. Pine tree done, raster saved. We can delete the raster, right? So we have a lake raster, we have a pine tree raster. But I think the pine tree is that it's actually dots, and you can't really see, but it's there. You see, this one is going to be an interesting one. They are just dots. To see it, you see they are here. So look for these dots here, and you see white spots there at just those locations. But believe me, they are there. Okay, you can't see, but believe that they are there. All right, so we've done pine, we've done lake raster. Let's do river. That's the last one. So raster conversion, vector to raster, to river. We have 10 minutes. When it's done, I think we're doing the last session. I don't care where we are. I promise you this is a very short lecture, but look at us now. We are almost 2 hours into it, aren't you? Don't mind me. Can't wait to get out of here. So please, in the exam, when you see a question, understand it. Without all these practicals. 30 by 30 resolution, blah, blah, blah. We have our river. There's a song about rivers, but I've forgotten the title. Okay, let's save it into the folder. So river raster, water raster. Let's intentionally call this one water raster. No, danger, river. Let's do that. River raster. No, you don't make that mistake. River is river for now. Okay, because lake is also water. So let's think that way. Water is a wrong name at this stage. Because we have lake. So save it, river raster. Say okay. We can delete the temporary layer, which is the rasterized layer. Okay, so now we have rasters, we have DM, clipped DM, we have lake raster, we have pine tree raster, we have river raster. Let's go back to our tutorial guide, which is actually the multi-criteria analysis. Step 2, he's actually doing what? Rasterizing. Are you okay? So everything here has been done. Okay, we've done all this. Okay, what's the result? This is what he got for his roads, and we got something interesting also for our river. So you can imagine if you had a lot of roads, it will look like the one we are looking at on the other end. Okay, so let's simply go to the next step. We are step 6. Wow, we're really moving. We can do what we call batch process for rasterizing. So you can try that in your own spare time, where you just do all the rasterization at a go. It's possible, it works, okay? But for the sake of time, let's try to skip some of these things. So we still rasterizing, okay? So we are step 10. You see, that's very fast, isn't it? We've really gone far. So 10, let's look at step 10. Once the processing finishes, you have 4 new raster layers loaded in the layers panel. You will notice that we have 2 water-related layers. We have lake and we have river, okay, both representing water. We can merge them to have a single layer. That's what we want to do, representing water areas in the region. Okay, so search for and locate for the raster analysis, raster calculator. So we are going to use what we call the raster calculator, and then we are going to add the lake and the river into the water raster. Okay. And here's the formula. When we get into the calculator makes use of formulas. We are all going to look at it. So let's go back to the QGIS, okay? So in QGIS, you just go to raster and then raster calculator. And then there you are, okay? So literally, this is how it works. You can simply say, I want to add the lake raster plus the river raster, and then you should get some result. Okay, now let's compare it with what I copied. Okay, they look similar. Okay, let me see. Maybe I'm not seeing my screen. Let me share it properly. Can you see the raster calculator, all of you?
Yes, sir.
Okay, that's fine. So I can just add, we can just add by clicking the layers. And so we look at the layers as if they are actually variables. Okay, so we can do 2x plus 1, 2x plus 200, you know, things like that. Okay, so here we are simply taking zeros and we are adding them to zeros at places where there's no water. Then we are actually taking where there's 1, obviously, then we still have the 1. Are you okay? I don't know. 1 plus 1 should have been 2. But let's look at the results. Are you okay? Okay, so we simply add them. And let's see that. So let's do lake plus river. And then we need to put it somewhere. Let's call it the water raster. So go to the CV, let's go to DM in the CV Ontario folder. You should have created your own folders and you're working with it. Let's call it water_raster. So with the raster calculator, you have to be careful. The logic may not be your usual, the way you know it. So you have to be very careful. We have layers of the same coordinate system and we're just trying to add them up. Okay, added. Okay, so look at the water raster. So in this addition, something more happened because we still have zeros and ones, but now let's switch off the river raster and then the lake raster. And you can see that we really have the two together. So this is the water raster. Why we call it raster? It's a question that you have to probably answer in the examination. Up to now, if you don't understand what that is, that will be a serious problem. So these are squares. That's what we are saying. Okay. If I zoom closer, you see that it's actually continuous and it's not breaking like you see it at a certain, smaller scale. Are you okay? So that's it. I'm going to zoom to bounce. Right click bounce. And I'm going to zoom to layer. Okay. So there's a project, and then all these are necessary to understand. This looks more like rivers, a river flowing into a lake. Start thinking that way. These pine trees are like endangered species. Are you okay? Start thinking that way for this scenario. Okay. And then so where is your project supposed to be situated? Should we be closer to the water? Does the project actually benefit from the abundance of water? In that case, you should be near to a water body. Okay, so that's the thinking for this. So we have all our layers. We have all our water as one layer. So that is what a tutorial is saying, and that's exactly what we have done. In step 11, okay? So we put in the expression. This expression means that we want to sum the pixel values in the first band of both the water rasters, which is what we did. Okay. All right. Oh, it makes sense. Makes sense. Okay, makes sense. It makes sense. Where there is a lake, you can't have a river. Get it? That is why the 1 + 1 = 2 will never happen. Wherever you have a lake, you can't have a river going through. Okay, so understand the logic behind some of the things we do. Okay, so step 12, the resulting merge raster will have pixels with value 1 for all areas with water, but you will notice that there are some regions where there was both water and water quality line. Okay, anyway, so those areas will have pixels with value 2. Okay, so you remember I was talking about the possibility of having 1 + 1 = 2. So take note of that, which is not correct. You can fix it with a simple expression. Okay, so we will double check that we don't have that effect by simply running raster. Yes, so that possibility may be there. That we've digitized and we haven't one because of the human error. So we are going to run this and correct for any possibilities of having 2. The value of 2 in this water raster. So let's go back to our QGIS raster calculator, and then we are going to say raster water merged at 1. That's his layer name. Our layer name is actually water raster 1 greater than 0. Are you okay? So we are just going to highlight the inputs. Water raster 1 greater than 0, and we are going to put it at the same place. So we're going to call it water raster. Hopefully we shouldn't have a conflict. So we want to place it, and then we just say okay.